Assalamu alaikum. So today we will be continuing with our differentiation lecture. We won't be actually learning uh, anything really new right at this moment. We will be just solving the problems which were given in the first class of the differentiation as homework. And after solving this, we'll move on to solving some questions, some sums related to the actual question paper sums, so that we get the gist how the questions are set and what type of questions do they tend to give in the real exam. Okay, so we'll start with the first one. The first one was given as 3x squared plus 6x plus 5, and this was y equals to this equation. Okay, now when we are asked to find the differentiation, see the terms, they're individually separated, isn't it? This is a term which is added to this term and added to this term. That means we can simply add two rules here. One is the summation rule, obviously. Another is what? On the individual terms, we're going to implement which rule? The normal differentiation rule, okay? So differentiating them should give us, we're going to implement on all the x terms where, like, we're going to implement the differentiation wherever possible where there is an x, okay? In this case, here is an x, we're going to differentiate this x, this term, then we are going to differentiate this term, and finally we're going to differentiate. We know there is an imaginary x to the power 0, so this now becomes 3 times differentiating x squared gives us what? 2 times x to the power 2 minus 1, that means 1, plus 6 into differentiating x gives us the power comes in the front, which is 1 times the power is 1, so 1 minus 1 is what? 0, so x to the power 0. Finally 5 times that power comes in front, which is 0 times x to the power 0 minus 1, which is minus 1. That means we're getting a value of 3x plus 6, and that is 0 actually. So it is also okay if we don't write the value of z. I mean, we don't write the 0 here, that's also correct. So this is also our answer to the first question. Now, coming to the second question, we have 5x to the power n plus 6x to the power n minus 1. Y equals to 5x to the power n plus 6x to the power n minus 1. You might ask, like, there's a term, new term n here, like what to do with that? It's completely fine. We don't need to do anything with it. Like, we will do it, but main factor here is our x. Since we will be differentiating it with respect to x, the only thing we'll be considering here is the x. So we'll be taking the constant in front and simply differentiating this x to the power n. Here n is a constant, okay? Like here, this 2 at the top is a constant, and we're just simply referring that constant to what? The x, okay? Similarly, here we will also refer that n to the x. Differentiating that with respect to x plus 6 times differentiating x to the power n minus 1 with respect to x. Now that should give us a value of differentiating x to the power n gives us what? The power comes in front, so that means n is going to come in front times x to the power what? N minus 1. So simply we will write it that n minus 1. See, it falls in the formula x to the power n. That simply just is the formula. Plus 6. Now again here x to the power n minus 1. This n minus 1 is the power itself, like the whole is a power to itself. So that whole power is going to come in front. So that will make it n minus 1 times x to the power. N minus 1 is the initial power, and we are going to subtract 1 from here. That means this whole minus 1. Okay, that should give us a value of 5n x to the power n minus 1 plus 6 n minus 1, finally x to the power. When you break the bracket, simply minus 1 becomes minus 2. So x to the power n minus 2. This is our the final equation. So we can actually write here that dy by dx is actually our this result. Okay, so that's our result to the second equation. Coming to the third equation, that's also pretty easy. So y equals to 7x to the power 34 plus 8x to the power 36 plus 9x to the power 108. I won't be doing this by breaking everything because it, like, for me, like, it elongates the video and it becomes like too large and it consumes a lot of time. In my case, you are supposed to do everything step by step, like up until you get used to it. Okay, up until you get used to it, just keep on doing it. If we differentiate it, we simply get what? 7 times 34 times x to the power 34 minus 1, which gives us 33, plus 8 times x times, sorry, not x, it's 36 times. The power is going to come in front, so 36 times x to the power 36 minus 1, which is 35, plus 9 times x, not again x, it's 108, times x to the power 108 minus 1, which is 107. So that should give us some certain value, and just calculate it and write it by yourself. You got the, like, portion how it should, like, set into the final result. Just simply simplify them, write the multiplied value and the multiplied value, and write them in a simple form. Now going back to the next question. The next question is e to the power 5x y equals e to the power 5x plus 6x squared plus 7. Okay, now differentiating it should give us dy by dx is going to be, let's do this later, but let's do the other part at first. We know this is very easy, which is 6 times what? 2, the power comes in front, times x to the power 2 minus 1. So that means it becomes 1. So we just simply can write x here, plus 7 times what? 0 times x to the power minus 1, because here we have an imaginary x to the power 0. So that's how we write, and we know anything multiplied with 0 becomes what? 0. This whole is going to become what? 0, isn't it? So we can just simply replace it with a 0. Now coming to the exponential part, e to the power 5x. Remember in the first class I have mentioned that differentiating e to the power x simply gives us what? E to the power x. Okay. Now in e to the power x, there are actually two functions. One is the g of x, which is e to the power, let's say, let's write it in this way. G of a equals e to the power a, right? And that a itself is another function, which is, let's say, 3 thrice x. Okay. So that means ga of x should be what? Replacing a in place should give us e to the power 3x. Therefore, this suggests, like, we can also represent a as what? H of x, which we have learned in the last class. That means f of x, if this was a totally f, like this actual e to the power, like 3x is the function, which is f of x, then g of h of x is basically equals to what? E to the power 3x, isn't it? Because 3hx is actually representing this above power. So that means what? We have two different functions, a function inside a function. Okay. If that's the case, then we have to implement what? The chain rule. Okay. Now, chain rule applies in which format? Fx equals to, I mean, f prime of x equals to what? G prime of hx. That means the differentiation of the outermost function multiplied with the differentiation of the innermost function. Differentiation of the outermost function multiplied with the differentiation of the innermost function. That means the outermost function is what? E to the power a or e to the power 3x. If it is, then we know according to this formula, like differentiating e to the power x gives us what? E to the power x. That means this remains same, e to the power 3x. Differentiating e to the power 3x gives us e to the power 3x multiplying with what? Differentiating that power itself, because it is another function here. So differentiating that 3x by dx gives us what? That should give us 3 times, when next to the, like x here is given as like 3 to the power x, where x has a power of what? 1. So that 1 is going to come in front, times x to the power 1 minus 1. So x to the power 0, and anything to the power 0 is what? 1. So this becomes also what? 1. This is also a 1. This is a 1. Therefore, we have a final result of 3 times 1, which is 3 e to the power thrice x. So this is our actual result. That means what should we do here? I'm giving you a few seconds. You should pause the video and try it by yourself. Just instantly pause the video and try it by yourself. What should be the answer? If you weren't able to, it's completely fine. Where we do it together. So we know here we have two functions. One is the c to the power 5x. Another is that inside portion. Like one is the outermost function, which is the e to the power something, and the other is the inside function. So e to the power whatever it is, differentiating that gives us e to the power that itself times the insider function, the power function. When we differentiate them or differentiate it, we should get 5 times. Like we will simply differentiate it as a normal function. So 5 times x is going to be simply 5, because x to the power 1 becomes what? After differentiating them, after differentiating it, it becomes 1 comes in front times x to the power 0, 1 minus 1, which is 0. So that becomes 1. So simply we are multiplying with 1. Finally, we have the answer 5 e to the power 5x plus 12x. So this is our final result. Okay, hope you got it. Let's move on to the next question. Let's sort of a similar type of question. Fx is equals to e to the power 6x squared plus 7x. This is also easy, trust me. Try it by yourself. Now you'll be able to do it by yourself. Just consider this, the outermost function as a function, then consider that inner function as a normal function. Like if we have, let's say, a function of hx equals to 6x squared, then differentiating, like finding the prime of it should give us what? Differentiating it should give us what? 6 as a constant times this x squared. After differentiating it, what should we get? The 2 comes in front times x to the power 2 minus 1, isn't it? That means 6 times 2 times x to the power 1, which is 12x, isn't it? So that means differentiating this should give us, but like by differentiating the outermost function, that gives us whatever it is itself. It just repeats itself, e to the power 6x squared. But again, we have to differentiate the innermost function as well, which gives us what? Simply gives us 6, the constant value, then 2 times x. Okay, that's our innermost function's differentiation. Finally, we have 7x, which gives us the value 7, because here for the x to the power 1, if differentiating this x gives us 1 times x to the power 0. So that is actually equivalent to 7. So finally, we have 6 to the 12, 12x e to the power 6x squared plus 7. And that is our final answer for f prime of x. Okay, that's our, that's actually our question number 5. It was. Then moving to the question number 6. Question number 6 is also really easy. Let's do it with a different color. So e to the power x to the power n. So simply just differentiating it gives us what? Differentiating this outermost function gives us whatever it is, e to the power x to the power n, times we have to differentiate that power now. So differentiating that x to the power n gives us what? This should itself give us n comes in front times x to the power n minus 1, isn't it? That should become our actual function then. So finally, we can actually simply write here n times x to the power n minus 1. Means this is actually our n into x to the power n minus 1 e to the power x to the power n. So that's our final result. Hope you got it. Now moving on to the next question, which is 3 sine x 3 cos x minus 3 cos x cos 3 cos 2x minus 3 sine 4x. Okay, so we have a fx equals to 3 sine x plus 3 cos x minus 3 cos no, yes, 3 cos 2x minus 3 sine 4x. Okay, remember in our last in our last class, I've shown just immediately in the last lecture, I have mentioned a way to actually solve sine and cos function. Here we have also like two different functions. I mean, one is the outermost function, and another is the innermost function. Okay, I'm not talking about the whole function. I'm just talking about the individual terms here. These terms here. Okay, for sine x, it is actually the outermost function is the sine whatever is inside the bracket, and that whatever is inside the bracket, that is another function. Okay, so we have to deal with it in that way. We know differentiating sine x gives us what? Cos x. So cos x, it should be, and we have to differentiate whatever is inside that sine x. In this case, it was x, so we're going to simply multiply the differentiation of that x, and we know differentiating x gives us what? Simply differentiating x gives us 1 times x to the power 0, so that is equal to 1. So we can just simply write here a 1 minus, plus. Similarly, we know differentiating cos x gives us what? Minus sin x. So negative sine x, and with it we have to multiply with what? The differentiation of the innermost function, which is x is the innermost function, and differentiating it we get 1. Okay, now coming to the third term, which is 3 cos 2x. Now we have the constant at the front, and we know differentiating cos 2x gives us, the cos function itself gives us what? Negative sine x. So negative sine, just don't simply write x, write whatever is inside the, the function, inside the cos. You have to consider this as a bracket. Okay, even if no one writes and you don't write, still that innermost part, like that part is actually inside that cos function. That's the inner function of the cos function. So we have to write that inner term as well, because that's what we are dealing with. So minus 3 minus sine 2x, and now as the term, like we have to differentiate the innermost function of the cos function. So the innermost function is what? The 2x. So differentiating 2x gives us what? Differentiation of 2x, we know that 2 actually is a constant, so it doesn't have any effect, so it comes in front. It will get multiplied, it will come in front, and we will have that x inside. So differentiating x gives us what? 1 times x to the power 0. So that simply gives us a value actually 2, isn't it? So if we get the value of 2, that means we have to multiply with it a simple 2. Finally, we have 3 times sine 4x. So differentiating the sine 4x gives us what? Cos 4x. So multiply with cos 4x. And hence, we also need to multiply the differentiated value of the innermost function, and we have a 4x here. We'll get a 4 times differentiating x gives us what? 1. So that's our final part, which is 3 cos x. Sorry, no, it should be minus now, because minus times multiplied with plus gives us minus. So 3 sine x, again minus times minus, it gives becomes positive. So 3, and here's a 2. So 3 2s are 6. So 3 2s are 6 sine 2x. Finally, we have 3 times 4. This 4 is not inside, okay? We are multiplying this for the innermost functions differentiation to the outer part. We are multiplying it with it. Okay, so that becomes 4 times 3, which is 12 cos 4x. Okay, so that's how we differentiate such function of like trigonometric function. Okay, I hope you got the way actually how it solved, or how we solved it. Now coming to our 8 number question, which is 7 sine 3x plus 1. So yeah, fx or f of x equals to 7 sine 3x plus 1. This is also in similar way we're going to deal with it. So 7 is a constant. So we are 7 there. When differentiating sine x, differentiating the function sine, we know the differentiation of the function sine is what? Cos. So simply write cos, and whatever was inside it, we should just repeat it. Finally, we have to differentiate the outermost function and multiply with the whole of the cos x, not just the innermost portion. Like we're not going to multiply the differentiation of this with the innermost part. Like we are not going to multiply with the innermost part. We're going to multiply with the outermost part. Differentiation of the innermost part with the outermost part, if that makes sense. So simply differentiating the 3x plus 1. So differentiating 3x plus 1 gives us what? We know this itself is an equation, so we can write y equals to, if we would consider 3x plus 1 as a function. So dy by dx gives us what? 3 times 1, because differentiating x is gives us 1, plus 1 is the constant, and we know differentiating a constant gives us a value of 0, because here's an imaginary x to the power 0, and you're differentiating this x to the power 0, the 0 comes in front, and if 0 comes in front, here is 0 times x to the power minus 1, and we know anything multiplied with 0 is becomes what? 0. So here we have written 0. So that means the differentiation of the innermost function is actually what? 3 plus 1, 3 plus 0, which is actually 3. So our final result is 3 7 21 cos 3x plus 1. Okay, that's our final result. Now, moving on to our question number 9, that is 7 sine 3x plus 1. This is also pretty easy. 7 sine 3x plus 1. Now this 1 is added to the whole function, not just simply the innermost function, innermost part. Okay, this 1 is added to the outer portion, so outer region. So we have to deal with it separately. Now differentiating this function fx gives us sine 7 as the constant value. So 7 remains the constant there. Then we have differentiating the function sine gives us what? Cos. So cos 3x. Now differentiating the innermost function, which is 3x. So differentiating 3x is 3 times we have what? Differentiation of x, which is actually 1. So that's our this portion's differentiation. And finally, we are left with 1. So we know 1 is a constant, and there should be an imaginary like 0, x to the power 0 here. So differentiating that x to the power 0 gives us 0 times x to the power minus 1, and we do have the constant 1 here. And we know anything multiplied with 0 becomes what? 0. So simply this function or this part will become 0, and we'll be left with 21 cos 3x. Okay, so that's our final answer. Finally, we have the last question, which was 7 sine 3x squared plus 1. F of x equals to 7 sine 3x square plus 1. Oh, it was just the outermost part. 6 square plus 1. This is also the same way we have to deal with it. So 7 f prime of x is actually 7 times differentiation of sine is cos, and repeating whatever was inside it, 3x squared. Now we have to multiply with it the differentiation of the innermost function. Now the innermost function here in this case, let's say, is what? Let's say g prime of x is given as, or h a prime of x, like whatever it is given as, let's say, 3x squared. Now, sorry, not prime, it is simply just g of x. G of x is represented as 3x squared. So that means our prime value should be, our differentiation of 3x squared should be what? The 3 remains there, multiplication with the differentiation of x squared. And we know the differentiation of x squared is what? 2 times x to the power 2 minus 1, which is x to the power 1. So that means we simply have a value of x to the power, 6 times x. So simply we will have the term here 6 times x. And finally, the differentiation of 1, which is a constant. And in our last problem, we just saw differentiating 1 gives, or any constant value gives us what? 0. Now, finally, just simplifying the expression gives us 7 6 42 times x times cos 3x squared. So simply that's our final result. And with that, we are actually done with our homework. If you are able to solve all the questions, very good. If you weren't able to, it's completely fine. You are doing pretty well. Just keep on following and keep on having the pace. If you struggle, then redo the works. Eventually, inshallah, you will get it. Now we are going to do some sort of like question paper type questions. Before that, there are oftentimes they ask you to find certain type of like related to quadratic equation, a question related to the quadratic equation. Okay, I tend to ask you that sort of questions. Now, trying to deal with that, let's directly implement a question, implement like a simple, like, introduce a question here. Let's say they have asked you to find the gradient of a chord. So gradient of a chord where the chord's equation is given as y equals to x squared, joining the points x coordinate p and p plus h. Joining the points, so joining the points, I'm sorry, this is the chord of the equation, this one, joining the points p and p plus h. Okay, that means try to understand the question. Gradient of a chord of y equals x square. Try to plot the y equals to x square. How does it look like? The y equals to x square actually simply looks like this. Okay, this is how a y equals to x square curve looks like. Now, if you are unable to freehand draw it, or unable to know, like you're not able to know how the graph looks like, just simply place some values. Let's say at x equals to 0, what is the value of y? At x equals to 1, what is the value of y equals to 2, or like y? X equals to 2, what is the value of y? X equals to 3, what is the value of y? Like try to place them, like try to place the dots there and try to draw a smooth curve, and you'll see this is what the graph looks like. Now they're saying that this simple, like this curve is joined by 2 points p and p plus h. So let's say p is over here somewhere, and these are actually like x coordinate they are actually saying. So let's say p is somewhere here, over here. So if this is p, and they're saying that with that p there is a added h, that means this value is, let's say, h. So p plus h becomes like it goes to that portion. Now if there, like we extend or join these 2 points, that forms a chord. Okay, this is known as the chord. If we join 2 points like this, that point is known as a chord. Now they're asking us to find the gradient of this chord. What should be the gradient, the m value? What should be the gradient here? So what are we supposed to do is we have to find actually at first the y coordinates of each of them. Before that, if we have like this chord is like it looks like a straight line, isn't it? Because it is a straight line, and the straight line has the equation of what? Y equals to mx plus c, isn't it? Now we can actually find, or we are actually supposed to find that m value over here. In order to do so, we need what? Like a straight line curve has a like we can find the gradient of a straight line curve in what way? We know m equals to del y by del x, isn't it? That means dy by, I mean the change in y by change in x. But though we have the x values here, let's say these are the x values given. This is the x coordinate of this point, and that's the x coordinate of that point. But we don't know the y coordinates. Then how are we supposed to? Isn't it? Try to guess like what can we do to find the coordinates of y. I'm giving you a few seconds. Or you can pause the video and try to guess it by yourself, because it's very like a trivial situation, and this is like sort of actually easy. You have actually equation, isn't it? This car, and obviously you don't have the equation of the straight line, so you might think that I don't have the equation of the straight line, so I'm unable to find the coordinates of like y coordinates of these points. But think one thing, that in this two of the cases, like in this two position, both the y coordinate of this whole curve, I mean this curve, this quadratic curve, and the straight line are in the same. Like they meet at a certain point. That's why like what does that mean? If let's say I'm going in that direction, I'm coming in that direction, and you are going from this direction to that way, and we are meeting somewhere over here. That means what? We crossed our paths, and we were somewhere like in the moment we were in the same position, isn't it? If we are moving like apart, like if we're crossing each other, obviously if we crossed each other and we met somewhere, that means what? Our position was same. That's the same thing. Like let's say I'm coming from Gulshan. I'm coming from Gulshan to let's say Shine College, and you are coming from somewhere. Let's say somewhere Mohammadpur or Mirpur to Shine College. We met at a certain point, isn't it? Which is the Shine College. Now that means what? That is the common point for us. We met at the same point. Similarly, here the position, like this curve and that straight line met at the same point. That means the y coordinate, x coordinate both are same. For the example, don't take it otherwise. It was just an example. And so we can actually simply find the y value from this. So y equals to x square. That means y equals to placing the value p in place of x gives us what? Y equals to p square. And placing p plus h in y again gives us p plus h whole square, isn't it? So that means we got two y values. Now if we use the formula y2 minus y1 divided by x2 minus x1, that is enough for us to find the value of the gradient. So that is y2 is, let's say, p plus h whole square. This is, let's say, y2, that's y1 minus p square. So that's our y1, and x2 is our p plus h minus p. So p and p gets cancelled out, and if we like simplify or break the brackets, that give us p square plus 2ph plus h square minus p square divided by h. That p square and p square gets cancelled out. We are left with 2p h plus h square divided by h. If we take h common from the numerator, we get 2p plus h divided by h. So this h and this h gets cancelled out. Finally, we are left with what? 2p plus h. Okay. So that's our final recipe. That means this is the actually gradient of our chord joining the 2 points. Okay, so this sort of question can also come. So you're not supposed to panic and at such questions. Rather, deal with it with full confidence that yes, you can actually solve them. Next, we have let's deal with some question paper maths. Okay, so